Hey guys, this is Alexander here, and I'm actually going to be covering some of the basic setup of the new Veil-Evasion HTTP request AES Encrypt um, shellcode inject method or module. The thing here is I want to cover some of the basic simple layout, understand a little bit of the infrastructure and some of the best practice uses so you can get the most out of this module, and also explain a little bit behind my methodology of sandbox evasion and maybe do a little demo here. The first thing we want to take a look at is the basically target network. In certain high security environments, sandbox appliances are definitely being used more and more. Everything from Cuckoo Sandbox to FireEye, open source stuff as well. There's different virtualized and hardware-based sandbox appliances out there. But let's just say we're going up against FireEye for this demonstration. The first thing we're going to take a look at is the Cobalt Strike team server. This is probably your most critical asset. It's your C2 infrastructure, and in this case it's going to be our long haul. Also take a look at and take note of is the web hosting, which is separate from the C2, and it's its own VPS instance, preferably outside of the current IP range of your C2. That way, if this VPS does get burnt down the road, you're not actually burning the entire C2 infrastructure. That's important to realize, and that was the reason behind this. In certain cases, we've deployed, let's say, a drive-by a payload, and it actually burnt our C2 infrastructure being in the same IP range. So let's take a look at the target network. Basically, you have a target system, and we're also going to deploy the binary through some magical method, maybe email phishing, drive-by, or whatever method of your choice. So let's take a look at the independent architecture that we have set up here. As said before, the VPSs are separate, and the sandbox appliance will only be talking to the first VPS web hosting instance, which is separate from the C2. Secondly, let's take a look at the sandbox evasion method that we're using. So currently, the method that I employed was a sleep timer and an HTTP request key. The reason behind this is when using the sleep timer, you generally can control how long or how often the request will be made. That way, if you're conducting one request every second, it might be a little noisy and it might come up as a red flag. But in this case, I have it default to 60 seconds. So every 60 seconds, the Veil payload, once deployed inside, or most likely scraped through content filtering or some other method with their email filters, they'll basically be able to run the payload just like your regular target system would, but the difference is the attacker will not engage that generated HTTP key, which is the HTML source code. In this case, it's the WordPress.html. Here, the sandbox creates the HTTP request attempt. The web server obviously is going to return a 400 code, and that Veil payload is going to sleep for 60 seconds. The important thing here is to understand that certain sandbox appliances have different methods to defeating sleep. Obviously, sandboxes only have a certain or a finite amount of resources and time to complete. Large enterprises might be analyzing hundreds to thousands of binaries and documents a day. So time is critical, and most sandboxes don't last more than 60 to 70 seconds. At max, maybe even 2 minutes on a certain payload. The thing that they kind of use to defeat some of these sleep calls, they'll basically speed up the architecture itself. Basically think that the CPU time is way faster than human possible, that way tricking it to think that 60 seconds has elapsed. They also use multipath exploration, which can actually jump sleep calls, patch sleep calls, or even load into memory different segments of code. In this case, since we're using a staged payload, we defeat most of those methods. They can speed up that code as much as they want. That key is not going to be there until you deploy it. So let's say if you wait 10 minutes and deploy that key, just to be safe, that Sandbox might make 1,000 requests, but it's not going to change the fact that that key is not there to decrypt the actual shellcode inject method. Also, patching. If they do patch or sleep code, they're going to go right exactly to the same segment again, the HTTP request. And lastly, if they do multipath exploration and they attempt to load in different segments of code, they possibly could load in the decryption method or jump to an MD5 hashing method. And at that point, it's not going to do them any good because all they're analyzing is they know there's some type of decryption routine. The key here was to perform the most successful sandbox evasion, but at the same time, do not leave as many indicators that sandbox evasion is taking place. If you guys ever use malware.com, it's a online cuckoo sandbox, and they actually will run whatever binary or sample you give them, and they'll give you an outputted result. The interesting thing is in certain cases it will tell you sandbox evasion techniques have been employed and different things like that. We obviously don't want that to be a trigger or even trigger admin. Worstly enough, having that FireEye appliance and start scraping your web server, which we've had happen to critical C2 infrastructure in the past. So now we've covered some of the basic of sandbox evasion. It's time to employ. So let's say 10 minutes has elapsed. That payload's still running in the background, have its own process. And then after successful HTTP code 200 has been returned, the payload attempts a decryption process. It's currently using basically a static HTML page that has a random string in it, so every time it's differently generated, and that gets scraped with the request library within Python and brings that in and then does an MD5 hashing algorithm against the entire HTML source code. Once that's completed, the 16-byte key decrypts the payload or the stager, which is the shellcode inject method, and then next thing you know, you magically get your your callback to your C2 infrastructure. In this case, we're going to be using Cobalt Strike's beacon. So let's take a look at our setup in Veil. Here we have, in this case, it's going to be 29. So let's use 29. And we have some simple options. The ones that are standard compiled to XE, of course, we're going to use that. And then HTML file path. This is basically going to set the output of the HTML location. And also, at the same time, it's also going to set the sleep target server. Those three options I suggest changing around, but are not mandatory. In this case, the sleep timer, which is set to 60, is a pretty good amount of sleep. It does not have a jitter built-in yet. Maybe I should probably add that on later down the road. But also, the target server will automatically pull apart the website name and also the URL, full path URL, and scrape that out and save it to the root desktop as WordPress.html on your desktop. So let's go ahead and generate this since all the options are set up. So we're going to use Windows interpreter reverse. We're going to use, reverse HTTP. In this case, we're going to enter the localhost number. In this case, we don't have independent architecture, but we're just going to simply set up a small web server using a simple HTTP server here and replicate what would be conducted in real life. We're going to use port 80. Okay, so let's go and grab that handler file, which in this case, if we were using Metasploit, we would be using that. But in our case, we're actually going to be using Cobalt Strike, so we're not going to need that. We're actually going to go and grab the executable. Let's go ahead and grab that executable. So here's our demo test. Unfortunately, I don't have the share drive set up, so we're going to have to move it here quickly. Okay, so now we actually have the payload moved onto the Windows box, and we're just going to simply run this without actually the HTTP server set up, just to kind of see what the functionality is. As you can see, it's going to start up. It's actually going to start up its rundles. At this point, the actual application is not going to launch, but it's going to stay active. It's also going to conduct those tests. So let's move back over to our simple HTTP server. Let's set that up, but let's name this WordPress something else. In this case, let's do it like one in there, just so that it doesn't actually engage. So we're actually going to start serving up that HTTP port. So any second now, we should actually be receiving that callback. Alright, there we go. So the 404 message was returned, basically saying that that WordPress HTML file was not there. The decryption process did not take place, as you can see, and the program is still actually running. That would be 60-second intervals. So let's go ahead and change this back before the second interval comes up. We're going to actually go ahead and put that as WordPress.html. Alright, so at this point we're actually going to bring back up the Python server. That way we can actually conduct the execution. You can actually visually see it take place on the Cobalt Strike side. As you can see, it's still running in the demo. Any second now we should actually see a callback. So let's go ahead and open up our beacons window just so that we know when that landed, and we can also interact with it. Alright, there we go. And we actually just got the beacon callback. So let's go ahead and interact with that specific beacon. Let's change the sleep time to go interactive here, just so we can actually conduct some commands here, just to show that this is a true beacon here. We're also going to just run it shell there. But at this point, the process is still running as demo test. I didn't automatically migrate, but you could easily do that, jump into that process that user actually owns. But at this point, that's about it. And we're going to make sure that this dir comes back to show the successful stage actually conducted. By default, beacon sleep for about 60 seconds. So let's get another 5 seconds here before we get a call back again. Alright, there we go. As always, you guys should subscribe. Also, there should be more videos coming out on my channel. Everything from Tradecraft to actual tool development. At this point, I have GitHub, and I also have a blog at cybersyndicates.com. The links will be below. As always, please subscribe. Have a good day.